Good morning, everybody, and welcome to this first webinar. The topic is on transparent wood and on a project that was recently funded on this new, very new material. You will have a possibility to listen to different talks given by different speakers who will try to cover all the aspects related to this material, and we'll try to provide you an overview on the potential of this very new material. The webinar is intended to be interactive, so I invite all of you to take to keep your mobile phone with you, because in a few minutes you will be asked to do something because we want to know your opinions about the transparent wood, about this new material. There will be at the end also a question and answer section. I would invite all the participants to write in the chat of the Zoom platform questions, comments that we'll raise during the webinar, and we will try to do our best to answer to all your comments and questions. So this is the agenda. It's quite rich, and we have different talks that cover the different aspects connected to the transparent wood. And we can start with a first interaction. And we would like to know what comes in mind, in your mind, when you think about transparent wood. Maybe you have already heard about this noun, and just scan the QR code you see here. Okay, let's see what comes to your mind when you think about the transparent wood. The biggest is the word. The biggest the largest is the number of answers provided on that word. You see that is still in evolution, but you see transparent wood is considered as a material, and you see also glass. Many of you consider transparent wood as a glass, and it's not surprising to see also that some people consider transparent wood as a new material. And also it's quite funny to see that some people have already in their mind some possible applications of the transparent wood. Well, good. Okay, you see the answers were quite heterogeneous, but it's reasonable to collect such comments. We will see. We will have some other occasions for other polls during the webinar, just also to check whether you are still awakened or not. Okay. We can start with the first speaker, Stefania Fortino from VTT, Finland, who will comment about, will describe the project that is behind the concept of transparent wood. Stefania, the virtual desk is yours, please.
Thank you, Giulio. We'll present shortly the project. We'll give some general information. We started this project within European call, and it started in January this year, and it will finish at the end of 2026. We have 13 partners from 10 countries representing universities, research institute, and industrial companies. And actually, you see at the end of this slide the link to the website. You will find all information about partners and also about results, ongoing research, publications, and so on at this website. Well, actually, this material is innovative, is sustainable, and as you already wrote in the answer previously, it's a possible substitute for glass, but also for plastics. That's why it is very interesting in different sectors, like construction, automotive, electronics, and furniture. This is not a new material in the sense that it was studied already for many years, 15 years, especially in Sweden. KTH in Sweden has developed the material from a research point of view, but some properties such as optical properties and functionalities should be still developed. That's why in this consortium, many experts around Europe, experts in different fields like wood multi-scale modeling, chemistry, manufacturing, were interested to join in a consortium to better develop this material. And the hope is that it will enter the market because it is not yet in the market. So our objectives are to create artificial intelligence-driven multi-scale methodology for this material and for other composites based on transparent wood. Then we should support this by using safe and sustainable by design framework, which is promoted by the European Commission in order to pave the way to a green and sustainable transition. And both artificial intelligence and safe and sustainable by design tool will actually contribute to increase innovation for small, medium, and large industrial companies for sustainable products based also on this new material. Numerical tools developed in this project are one of the main focus because we won't develop just the material, but also computational tools to be faster in producing, for example, specific products, transparent wood. And this will be shared in the European EC platform from Switzerland, SICAM Institute. So this is a project very interesting also for researchers, not only for industrial people. Here you see the structure of the project. The core is composed of computational work packages from work package 1 to work package 6. So we have multi-scale modeling from atomistic scale to structural scale, and these work packages are supported by experimental work carried out in some of them. So interaction between computational and experimental work packages will allow to carry out research work in successive work packages from work package 11 until work package 11. So in this, you will have development of polymers, chemicals, and all components of the transparent wood. Then we will have life cycle analysis in work package 12 in combination with safe and sustainable by design tools. And dissemination, communication, exploitation in work packages from 13 to 15. And finally, management and coordination in 16 and 17 work packages. We have so many work packages because this call was based on financial scheme called lump sum that now is very, very much used in European projects. Here you see the concept of safe and sustainable by design that we use in this project, and it is also used in many of these resilience-based projects funded by the European Commission. So there are two phases, one design phase in which we define properties and performance, design principle, business concept, and this is carried out from the ideas to the concept creation, development, and experiments. As I said, there are especially some work packages focusing mainly on computational models and experiments which will support the models. Then there will be assessment phase with life cycle analysis and development to make this material as a possible new material in the new market in Europe. And then we will go from testing and validation to first steps to the market, prototypes, demo cases, and then dissemination, communication, exploitation. Here there are some planned industrial application. Of course, this is just the future because initially we have to select some prototypes for the demo case. For instance, some transparent wood sheets that will be used in different of these applications. But of course here you can see something like a seat application for chair, aesthetic glasses application in the furniture, and construction field, automotive field, for instance, front face decorative exterior part, interior surfaces like guide, and in electronics field, different lamps, electronic luminous films, and so on. In the construction field, there are many applications from windows to decorative elements, flooring, public transport also for line elements and so on. So actually, during the webinar, you will hear about possible application of this material. So you can get some ideas, also some suggestions to us for future applications. We carry out the work in this way. So actually, there is the research with first production of transparent wood sheets from the original wood. As you see from the left to the right, we have original wood, delinified wood, and transparent wood. This will be better explained in the next presentation. This part, which is more experimental, is coupled with the models. So as I said already, these experiments will strongly support the development of models, and the models in turn will allow to fastly develop the transparent wood and wood composites for industrial use. And this process will also be carried out in collaboration with an external advisory board, which will also include research institute and industrial companies. So we will work not only among consortium partners, but also with this external advisory board, and of course with the community through dissemination and communication. So at this point, I have finished my short presentation of the project, and my colleagues will continue with the other presentation. Thank you.
Thanks, Stefania. We will go on. So now you have an overview of the project that is behind the concept of transparent wood, and now you will see something more related to the transparent wood that will be presented by Eva, Vanessa, Bruno from Politecnico di Torino. Eva, the virtual desk is yours.
Hello, everyone. Before we dive into the concept of transparent wood, let's take a moment to reflect on what transparency materials truly means. So not from a technical standpoint, but from a sensory and expressive perspectives. So transparency is about how light interacts with matter, and how it reveals or conceals, and how it evokes emotion and ideas. It's this expressive power that shapes our perception and use of materials. So let's start with a material that is like a synonymous of transparency: glass. Glass is one of the oldest material known to humanity, yet it continues to evolve in its expressive potential. Think about it. Today we can find glass in every imaginable color, glass that filters light to create a unique place of color, or textured, three-dimension glass that offers some tactile quality, very far beyond the smoothness of the traditional glass. Yes. And depending on how glass is processed, glass can offer either transparency or translucency, creating a different degree of opacity effect. The level of translucency can even emerge from the glass macrostructure, give it like a dynamic, almost living quality. As for example, yes, as you can see, this macrostructure of glass gives different perception and sensory aspect of glass. So for example, does it feel like organic, amorphous, this glass? Okay, let's continue with another material family, which is plastic. Unlike glass, plastic is generally lighter and less fragile, making it suitable for a wide range of application. Yet plastic also has a unique visual identity. Take this material that is PMMA or acrylic glass, for instance. It can be infused with endless colors, as you can see in this sample, and its structure allows the edges to conduct also light in these samples. Yeah, as you can see, the edges conducts light, and it creates like some fascinating optical effects. This versatility opens up new possibilities for creative some expression and innovation with this material. But plastic doesn't stop at just being visually appealing. It also be like smart. Consider plastic that change transparency or translucency with temperature, or those that can like polarize light and create dynamic optical effect, as these samples do. This enables plastic to interact with the environment and also users through innovative ways. Now, let's talk about materials that aren't naturally transparent, but achieve transparency through clever ways of production. For example, honeycomb panels allow thick sheets of plastic to become translucent, for example, in these samples. Or, for example, take this incredible material, the aluminum foam, this one, by embedding some air bubbles during the process. The resulting panels feature like an amorphous transparency that blurs the line between solid and also void, adding like a sculptural quality. And lastly, we explored techniques that enable light to pass through otherwise opaque materials. For example, fiber optics that are embedded in wood panels can obviously transmit light, creating some visual effect. Yeah, and also metals can achieve transparency, some kind of transparency through chemical photocutting process that like produce these very ultra thin panels with ultra thin drawings and patterns. All these examples demonstrate how transparency can be achieved across some unexpected mediums and unexpected materials, expanding the horizon of material innovation.
Thank you, Eva, for the presentation. And now let's try to focus a bit more on the concept of transparent wood. And so let's see how, from a technical point of view, transparent wood can be produced, and let's describe how when it was discovered and the current state of the art related to this material. So if you listen about the concept of transparency, we define several times transparent materials. If you type on a dictionary like the Merriam-Webster dictionary, the transparency, the noun, you find that transparency means the quality or state of being transparent. But from a scientific point of view, it's better to use the term transmittance. The transmittance is one of the interactions that light may have with any materials. And from an overall point of view, from a general point of view, any incident light with a certain wavelength may be partially reflected by the surface of a material, can be partially absorbed, or it can be also transmitted. And usually the transparency is strictly correlated to the part of the light that passes through the material, that is the transmitted light. And from a quantitative point of view, you can define a parameter that is called transmittance, that can be also expressed as a percentage, as the ratio between the intensity of the light that is transmitted, so passes through the material of a certain thickness, related to the incident light, so the intensity of incident light. Usually, transparent materials have a transmittance that is beyond 80% or even 90%. Maybe when you were very young, you had such an experiment that belongs to the physics of a material. So you put a pencil into an empty glass and you pour some water just to fill the half of the glass, and you see that the light that crosses the part of the pencil that is in the air is different or has some differences with the light that crosses the water. This is because water and air have a different refractive index, that is the ratio between the speed of the radiation in vacuum and the speed of the same radiation with the same wavelength in the medium. and so the pencil seems broken, even though it is not. There are some laws behind this behavior, but usually the material transparency is strictly related to the possibility of avoiding any deviation of the light while the light crosses the material itself. This deviation is called scattering. If we look at any sample of wood, well, there's no choice to have transparent wood. You see some very small cycles with different types of wood. And so about 10 years ago, thinking about transparent wood was a sort of a nonsense, an oxymoron. This is because wood has a certain chemical composition, is made of roughly of three main elements: carbon, oxygen, and hydrogen. And these elements are structured, giving rise to three main components: the cellulose and the hemicellulose, that are two polymers, and the lignin, that is a big molecule. It's called macromolecule. If you cut a tree and you get wood bulk and you examine the microstructure, you will see that the wood exhibits some channels. The channels are filled by lignin, and the walls of the channel are made of cellulose and hemicellulose. Wood has a very complex architecture that is called hierarchical architecture, and you see considering the microstructure of the wood, the cellulose here is organized in form of fibers, which in turn are made of microfibril bundles. Each a bundle is made of microfibrills, which in turn refers to elementary fibrils that are made of cellulosic macromolecular chains. So the nature offers some nice examples of transparent materials. I put just two examples on the left part of the slide. So the jellyfish, and there's also an animal that is called glassy frog. The name glassy refers to the fact that the skin is transparent and you can see the inner parts under the skin. In 1992, Sigrid Fink was researching wood and had the brilliant idea of trying to make it transparent. This was performed by removing the lignin that fills the wood channels and replacing the lignin with some other materials whose refractive index should match perfectly, or should be very, very similar to that of the wood after the lignin removal. This way, the light passes through the lignified and infiltrated wood without any deviation, any scattering phenomenon. This concept was unreasonably abandoned for a lot of years until 2016, when two different research groups working not working together, published the first two pioneering works on transparent wood. One was from KTH, Professor Lars Berglund, and one was from University of Maryland in USA, from Professor Liangbing Wu. Now we know exactly, even though the material is very, very young, and so is undergoing a continuous evolution as far as the chemistry behind, as far as the technology that can be exploited for making making wood transparent. We know exactly that there are two main approaches, technical approaches that can be successfully exploited. One is to remove completely the lignin from the wood channels, and then after this lignin removal, to infiltrate a resin that can be polymerized or cured, and you get the final transparent wood. As an example, you see the SEM, scanning electron microscopy micrographs. The first one, the number one, refers to the delignified wood. You see the wood channel completely empty. And the second one is after the resin infiltration. So the polymer infiltrates in the channel and fills all the channels if the refractive index of the polymer is very similar to that of the delignified wood, you have, as a result, a transparent material. There's a second possibility. Instead of removing the lignin, you can keep the lignin, almost all the lignin inside, and you just use a particular chemistry to remove the chromophores from the lignin. The chromophores are responsible for the color and for the opaque character of wood. You get a material that can be compressed, and you get some transparent wood films, or you can infiltrate some resin, and then you get some transparent compressed wood. There's another possibility. If you make a sort of partial delignification, so you select the channels from which you want to remove the lignin, and you keep the lignin in other channels, you get the so-called aesthetic transparent wood. It's a material in between wood and the transparent wood, but you see that the wood keeps the texture, and so it's quite interesting, even though it's not transparent wood at all. This is just to compare the main characteristics of wood with other materials like glass, like metals or ceramics, and the transparent wood is a light material. Its stuff is not brittle at all. It's transparent, so has quite a high optical transmittance. You will see that the energy that is involved during the processing for the making of transparent wood is quite limited. Wood is a biomass, and so the carbon footprint is quite low. You will see also from the sustainability point of view that the low thermal conductivity is a key factor for providing some energy saving for some applications like the glazing. It's quite resistant to the environmental conditions, so rain, acid rains, and the UV radiation, and unlike the metals, does not undergo any corrosion phenomenon. But we have still some limitations that you can see in the right part of the slide. Okay, just to show you two examples. The left, this is an example of transparent wood we obtained in the last 2 months. And on the right, you see the pristine native wood, top left, the wood after delignification that becomes usually white. So there's a whitening, and then you see the transparent wood. The rule indicates that there's a limit in the size and also in the thickness of the native wood that can be processed to get the transparent wood. Okay, now let's have a closer look and let's see some samples of transparent wood. As you can see, these are small samples, and you see that even though the proper name is transparent wood, is a sort of translucent wood, but if you put a drawing or a text behind, you see that the light passes through, and you are able at a close distance to the text to read the text or to see the picture behind. Also, you see the quality is quite high. You see also that the lignified and then infiltrated wood keeps a sort of texture that follows the direction of the development of the wood channels. Again, it's transparent wood, but it should be considered a translucent rather than transparent, even though if you put on your fingers, you exactly see your fingers behind. This is the thickness. Limitations in thickness refer to some millimeters of thickness. The higher is the thickness, the higher is the difficulty to get well delignified materials, and then so the infiltration becomes more difficult. Okay. So, second moment of interaction. So the question which raises is which applications or application sectors you think are the most relevant for the transparent wood, according to what you listen. So Chiara Lacroix from STRANE Innovation will show us how it's possible to exploit new materials, including transparent wood. Chiara, the virtual desk is yours.
Thank you. So good morning, everyone. And first, thank you for sharing your ideas of applications, even though we cannot see them right now. But keep your ideas in mind, and let's dive into this interesting theme. Can we make business with transparent wood? That's an important question we ask ourselves in the exploitation part of the project. The objective is to make concrete use of the results. So it can be, for example, through the commercialization of products, by contributing to further research, by creating services, or even shaping policies. In any case, the aim is to maximize the project's impact. In the case of transparent wood, one key question is how can it be used in industrial settings and practical applications. And to understand that, we explore different markets to identify where transparent wood would be relevant. With this market exploration, we want to dive into potential market needs to understand which problems that are currently faced by different actors we could solve and which needs transparent wood could meet. We also need to consider the key constraints of each application to ensure that transparent wood is really aligned with real-life applications. And finally, we need to analyze competition to see how transparent wood compares and how it could be integrated. These three elements together allow to derive the value proposition of transparent wood so that we can focus our research efforts on what will facilitate the product's adoption. To do so, there are some key steps. In particular, if we want to see how transparent wood can be leveraged, we need to understand which are its key properties. We also need to understand how it compares with other materials to be able to identify its value added. And then, with these elements in mind, we can analyze the current applications of materials of the same type to first obtain a broad view of where transparent wood could theoretically be applied. And finally, we can dive deeper into these applications by considering the key constraints in these specific cases so that we can check if transparent wood could actually be relevant. And if so, to ensure that it will meet these key constraints. So I will now share a bit more about these 4 steps. First, considering transparent wood's properties. So we have covered that a little bit already, but a wide range of properties can be obtained. In a general way, transparent wood offers high transmittance, meaning that it allows most of the incoming light to go through the material. It also typically shows significant diffusivity. You also saw that with the samples. So scattering light, which can be an issue in some applications, but can also be an interesting element for some other applications and something that we can leverage. As you learned earlier, the obtained material is relatively light, which can have strong benefits, especially when the material is transported, so leading to fuel consumption reduction. It has relatively low thermal conductivity, which can be an advantage in applications at the interface of indoor and outdoor spaces. It can also have high mechanical strength and thus be used in demanding applications. Importantly, it is highly customizable, and properties can be tailored to various contexts, which is also why we need to consider a broad range of possible applications. And finally, in some cases, it can have a lower carbon footprint than other materials, as will be discussed later in this webinar. So once these interesting properties are identified, it is easier to see which applications could be relevant. Now, let's compare with other materials. The first element to notice is that we look at transparent or translucent materials, as we said before, because otherwise non-transparent natural wood can simply be used. Then, as previously mentioned, glass and plastics are 2 typical materials in that area. They can be transparent and allow a clear view. They can also be frosted when the objective is to let light through without allowing to see details. Transparent wood typically has less of a clear view, as you could see with the samples, but it also has benefits over these materials. For example, it is lighter than glass, it is more insulating, more impact resistant, and avoids the energy-intensive process of glass making, meaning that it can be relevant in some of glass's applications. Regarding plastics, it can have higher mechanical properties, as well as avoiding the use of fuelly petroleum-based materials. So that's an interesting direction as well. We can even look at more innovative materials such as aerogels or translucent concrete to understand which needs they're answering and which properties could be relevant. For example, aerogels are solids with extremely low density. They're extremely insulating, but they are also fragile and not fully transparent, compared with what can be achieved with transparent wood. If we look at translucent concrete, we understand that there can be an interest for materials allowing to let natural light through while keeping sufficient thermal insulation and structural properties. And this helps us identify where transparent wood could be relevant by understanding the strengths and weaknesses of both transparent wood and other materials. Now, if we look at applications of transparent materials, we see that they can play different roles. One of them is the protection from outside conditions while letting light through. It can be the case of windows. In that case, we basically want natural light to come in, but we want to be protected from outside conditions, such as rain. And we want to have a sufficiently high insulation to keep a comfortable temperature inside, which is why we use transparent materials such as glass instead of using just holes in the walls. We can also think of car windows, of these transparent panels that you can see at the top of the stadium on the top right picture, to prevent spectators from being wetted, but at the same time allowing sunlight to come in. For greenhouses, we want crops to be protected, again, but they absolutely need sunlight to grow. And ideally, that light should be diffused uniformly. We can also go further and think of aerospace applications. And well, in some cases, we want to be able to see clearly what is on the other side. But in other cases, we simply want to let natural light through. And in that case, transparent wood's diffusivity could be leveraged. Another function of transparent materials is containing products, often also protecting them from environmental conditions, but allowing users to see what is contained. And you can simply see here a few examples of that function in our everyday life. A totally different function is related to optical purposes. In that case, transparent materials are used to interact with light in a very specific and precise way. For example, with camera lenses or eyewear. Another significant application of transparent materials is in combination with artificial light. Not sunlight this time, but artificial light. They are used between the light source and light users. That's what we can see with ordinary lights, or in the automotive sector, in combination with LED strips. In some cases, they also act as the interface for interaction between users and the product, for example, with touchscreens. In interior design and furniture, they act as sort of separators for spaces and areas, whether it is between offices, in the bathroom, or for cabinets. And I could go on because there are countless applications of transparent materials, including the surface of solar panels, the medical sector, toys, or even aquariums. And all of these applications are a great source of inspiration to understand where transparent wood could theoretically be used. But, as anticipated, there are important constraints to consider. What you might have thought when seeing all these examples is that transparent wood doesn't seem adapted for some of them. And it is true that in some cases, it seems obvious that there are very strong constraints. For example, for optical purposes, well, we need an optical preciseness that would be hard to achieve today with transparent wood. If we consider the aquarium, mechanical constraints are extremely high due to the action of water, and that's something to consider, of course. In aerospace applications, lives are at risk, and we cannot afford to have material degradation due to the exposure to UV in space. And for medical applications, well, we need to ensure biocompatibility and go through extensive testing and certification. But even for applications that can seem less demanding at first, there are key constraints to consider. For example, we can look at car headlights and furniture. For the first one, transparent wood's lightness, transmittance, and diffusivity could be interesting. But to ensure that transparent wood can really be used, we need to achieve the required optical properties. We need to extensively evaluate resistance to weathering, to external conditions, which are key criteria in this industry. We need to evaluate the thermal behavior of the material due to the heat released by the lights. Of course, there are also strict safety standards, and transparent wood would be in competition with well-established materials and would thus need to be proposed at a price that considers these competitors. If we look at furniture, plates are usually used with a relatively high thickness of around 20 millimeters. Furniture also needs to have strong mechanical properties and to withstand stress, especially in places like hotels, in which clients might be, let's say, careless. Even though interior conditions are less harsh than, well, in the external environment, there are some elements to consider. For example, resistance to water or coffee to avoid the creation of stains, and resistance to cleaning with chemical products. We also need to consider how transparent wood can be assembled smoothly with the rest of the product. And well, finally, furniture is a sector in which sustainability has gained great importance, meaning that we need to ensure that the material is environmentally friendly through its life cycle, that it does not release harmful pollutants for consumer safety, and that an eco-friendly end of life can be assured. And well, the list goes on. That's a few examples, which is why it is very important to identify these constraints if we want to understand if and how we can actually make business with transparent wood. Then with these constraints in mind, we can look at materials that are competitors, as I was explaining for the car example, and examine if our value proposition is attractive for actors and also at a price that would be economically viable. For example, sustainability is gaining importance and some actors are willing to pay a premium for bio-based products. But the economic factor of price remains important. To conclude, here is a QR code for if you are interested in sharing your insights. We are still exploring potential applications of transparent wood and trying to understand which properties would be interesting for real-life applications, and also which key constraints should be considered. We are mainly focusing on the automotive, construction, electronics, and furniture sectors. And well, we're interested in insights you might have. So if you are in this situation, don't hesitate to reach out to us. You can use this QR code to book a short online meeting or contact us. I will also put the email address back in the chat for those interested. Thank you.
Thanks a lot, Chiara. My apologies for having not had the possibility to share the results of the poll we have had on applications and application sectors. I may comment that most of the answers refer to furniture, car industry, so automobile, structural and construction panels, windows, fiber optic, and art and decorative panels. So more or less, there's a sort of correlation with between your idea of potential application and what also we as a whole consortium within the AI-TranspWood project thought about possible exploitation. Now we have a second poll. We cannot promise that it will work properly, but we will try. You heard about sustainable material, safe and sustainable by design, sustainability. So what do you think about the possible definition of transparent wood as a sustainable, environmentally sustainable material? And now it seems works. So it seems that we are convincing most of the people who are expressing about that wood could be a good answer also as in the sustainability. Two people are fully convinced that transparent wood is not sustainable at all, and some people are still without a clear idea on the sustainability. So we can go on and we can try to have a closer look at the possible sustainability provided by transparent wood. So my colleagues from Politecnico will start now.
So thank you, Giulio, for this introduction. And again, thank you for this presentation. Let's try to answer this question about the sustainability of this material thanks to an overview of, let's say, the main steps of a possible LCA of the transparent wood. So going from the origins to the transformation, to the applications and the end of life of the material. Let's try with the origins. When we think to innovative materials at the present time, in this specific time frame, we have to think that we are more and more looking for new solutions that are, let's say, progressively creating alternatives to petroleum-based materials. When we think to transparent wood, we have to know that this is made of basically of two parts, as we just understood from this presentation, today's presentation. A part that is made of wood that counts around 80–90% of the material, and a part dedicated to resin, a matrix of resin that is around 10%, 20% of the material. The woods that are used for this for the transparent wood usually is poplar veneers, but several other species have been tested. Several other species of wood have been tested, like for example the balsa wood, brass wood, but also pine, ash, birch, and also stronger high density wood species like walnut have been recently tested. Furthermore, also bamboo is one of the most recently tested material in order to create this process of lignin removal and then resin infiltration, even if bamboo cannot be considered actually a wood material rather than a grass material. Anyway, also in this case, the results are promising, and of course, we can think to a material that has a quite quick growth. On the other side, when we think to resin, we have to know that the first, let's say, experiments with the transparent wood were carried out using polymethyl methacrylate or epoxy resins, as well as the most recent one use polyvinyl alcohol. And also in our project, we are going to try new biosource resins in order to increase also this aspect. Anyway, what we can say is that the main part of the transparent wood, so both the wood and the biosource resin, come from, let's say, a natural sourcing. And when we think to use of wood, of course, some aspects are important, specifically important. The use of selective, the practice of selective harvesting, so using just specific trees that are more abundant than others. The reforestation, so the practice of using trees that allows also planting new trees to replace the harvested ones, with a positive impact on restoring biodiversity or improving the soil quality. And of course, if we think to a mass production rather than the experimental level of production, of course, have to be assured the use of materials of wood coming from certified forests like FSC, so the Forest Stewardship Council granted forest, or PEFC, so the Program for the Endorsement of Forest Certification, that of course ensure that wood products come from a sustainability managed forest.
So something about the transformation of transparent wood. So one of the key areas of innovation in the production of transparent wood is the use of resins that need to be environmental friendly and are partially biosourced because this approach enhances the sustainability of material, reducing its reliance of petrochemical products. And researchers are trying to minimize the overall environmental impact of this production. So transparent wood demonstrates significant lower environmental impact compared to many fossil-derived materials in terms of global warming potential and natural resource depletion. And this is one of the key reasons transparent wood is being considered as a more sustainable alternative to materials like glass, plastic, and metal that derive from fossil fuels. Traditional materials like glass and plastics are typically produced through high energy processes that contribute to the environmental impact. And the production of transparent wood offer the potential for more energy efficient manufacturing because researchers are exploring mild chemical treatments that can remove lignin at lower temperature, reducing the need of high energy input. And so we can go to the next part about application of transparent wood, and then we go through the end of life of scenario of transparent wood.
Yes, another possibility to find sustainability in transparent wood could be in some applications. I will show you one possibility. The potential, in my opinion, is quite high and is strictly connected to the low thermal conductivity that transparent wood exhibits with respect to other plastic materials or even with respect to glass. If we compare the thermal conductivity of transparent wood, here you see an histogram where transparent wood is compared with a glass and with an epoxy resin, so a plastic material. You see that the thermal conductivity is much lower compared to both the other two material classes. And there's a research study that demonstrated that it is possible by using transparent wood and replacing the glass, and in particular the e-glass that is a glass with a low thermal conductivity. If you replace the e-glass with transparent wood, you will have significant cooling energy savings as demonstrated for 3 big cities, Hong Kong, Shanghai, and Chongqing in China. So there's also the possibility to indirectly estimate a sort of sustainability of transparent wood in these applications.
So what about the end-of-life scenarios of the transparent wood? So transparent wood is a very young material, and currently there aren't any indication regarding the transparent wood and end of life. No European or American or Far East technical standard are have been defined to give producer and researcher indication about the end of life of transparent wood. End of life of these materials is in research phase. So researchers are investigating and trying to find more information about the end of life of these materials. It's a specific scenario that is characterized by a growing interest in researches, but until now, research has focused more on improving technical properties and extending the useful life of the material. But if we try to define the end-of-life scenario for transparent wood, we can consider several scenarios depending on how the material is disposed of, recycled or recovered. Transparent wood, of course, is typically made by bonifying a natural wood through the process that we saw before. And we obtain a strong and lightweight material with could have a very long useful life, but we can consider a few potential end-of-life scenarios such as biodegradation, but also recycling scenario, even chemical recycling scenario, but also incineration in the case where transparent wood cannot be recycled. This could be an option, and we can generate energy and reduce the volume of waste. But we can also consider landfill disposal if recycling or biodegradation are not available. So as transparent wood becomes more common, it will likely be subject to environmental regulation that guide how the material should be disposed of, recycled or reused. And these policies could influence how industries handle transparent wood at the end of its life cycle, promoting more sustainable practices.
Okay. If we look at the previous poll on the sustainability of around 56% answer yes, it's sustainable, and 36% of the people say no, it's not sustainable. After this part, what do you think about the sustainability of transparent wood? Is still we will have the same outputs of the poll, or are you still not convinced, or you definitely say no again? Yes, as a matter of fact, we approach 68% of people voting for transparent wood as a sustainable material. We have still 8%, 2 people against sustainability in transparent wood, and we for sure convinced more people about the possibility of transparent wood to be sustainable, as the percentage of people who do not know exactly if it's or not sustainable is around 22%. We started from 36%. Thanks a lot. Okay, we can go on. There's we have other interactions. The next question is, let's suppose that transparent wood possesses sustainability features. Where do you think that the material has the highest potential for being environmentally sustainable? And where do you think that the science and the scientific community should focus all the efforts, all the scientific research efforts to improve the sustainability of environmental sustainability of transparent wood. We can go on. You heard that the transparent wood is within a project that is AI-driven. So let's have a closer look at artificial intelligence and the possible potential interactions with transparent wood. So this part will be described, presented by Kari Kolari from VTT, Finland. Kari, the virtual desk is yours.
Thank you, Giulio. And good morning for everybody and regards from cloudy Helsinki. So in fact, this project is very much concentrating on modeling and simulation. And in modeling and simulation in this context, I mean development of tools and methods which can be used to improve physical properties of transparent woods, like transparency, mechanical strength and ductility, and different manufacturing processes. Next one, please. AI is used in various approaches in the project, and to give an idea of how it is used, I will describe shortly 3 different examples where it is used. And the examples are related to microstructural modeling, multi-scale modeling, and kind of a process efficiency modeling. Next, please. So the first one is related to modeling of the complicated geometrical structure of wood cells. And this case, the focus is in the modeling of realistic cell structure geometry, including natural variability and randomness of the structure. And the idea is to get this modeling fast and reliable. So that's where AI has been used. And here the picture on the right-hand side shows the geometrical structure produced with AI, and it's very much the same as in the nature. And the next thing is also related to the wood structure, but in this case we are going to use AI to figure out how the small scale cell structure reflects in the bigger scale. If we have a glass or glass-like structure made of transparent wood, we want to know how the microstructure effect on the, let's say, ductility, stiffness, etc., mechanical properties of the final product in a bigger scale. And next one, please. And one important thing is related to, we have already discussed about the resin. So this is again the idea how the transparent wood is made. So there's original wood, a block of wood or plate of wood, and then at the next phase we remove the dark lignin from the wood and finally replace the lignin with transparent resin. Now the question is how to find a resin which is easy to use, it's biodegradable, and it's transparent. So for that process, development, we are using AI, and Antti Puisto in the next presentation, he will more talk about the process itself. But here the idea is to find a new material, monomer, which is easily polymerized and so that it is transparent, it has enough strength, and especially that we can infiltrate the material inside to the wood. So that's one. So the project is still in early stage, so we actually haven't yet, we don't have many examples of the uses of AI, but the results we have got already are encouraging, and we expect to get good results with using AI.
Okay, thanks, Kari. The next speaker is Antti Puisto, and he will talk about the possibility of exploiting successfully artificial intelligence for a reasonable, rational materials design. Antti, the virtual desk is yours.
Thank you, Giulio. Basically, we have experienced several different paradigm shifts according to this paper, 3 ones before, and now at the moment we are at the brink of the 4th paradigm shift. So the first one regarded studying materials based on experiments purely. Then we had incorporation of theory, then incorporation of simulation, and as the computational power increased, and all of these strive towards discovering of new materials. Now what we are moving towards is basically a database-driven approach where we collect and share the data that we have generated and of course continue generating still, and try to utilize tools, data-driven tools to analyze the databases in order to find correlations between the data and use AI to actually predict new materials, and then of course the loop continues. So when I'm coming from the background of materials modeling, it's most natural to talk about this in this context. So basically, in materials modeling, what we are often doing is taking raw materials, processing them in certain ways to obtain certain structures. This brings us the process structures causality. Then the structures will give certain properties, and how the properties depend on the structure. This is another causality that needs to be resolved. And then finally, the properties set into a certain environment gives us a certain performance, and this is another causality that needs to be resolved. But in the ideal case where you have all these causalities resolved, you can swap the initial materials at will, and then this will produce you a database of how this material under these processing conditions perform under this environment. And basically, then if you are able to ramp this whole process through several thousands of times for different materials, then you are able to learn using AI this chain of causalities, and you can reverse the question. So basically use inverse design to ask the question of what should be the raw material if I'm willing to obtain this or that performance. And basically this is the power of the AI in this kind of context. So it can actually provide you some information or some initial suggestions for the materials. And we have actually implemented this kind of process in a self-driving laboratory where we study different kinds of polymers and generate automatically database for certain polymer properties. And that is shown on the figure on the right-hand side. And then, of course, AI can also accelerate the data production. So it's not necessarily just for the inverse modeling, although that's also a powerful tool. But it can also help you in parts of the materials design by accelerating the processes, such as automating some of the data analysis and interpretation of the data. But also with the development of surrogate models, which can replace some of the time-consuming simulations and experiments. And finally, to guide the experiments and simulations, so telling you explicitly that this point is the one that you should test next in order to maximize the information content from the simulation or the experiment. And this is, I think, the current state of the art, or towards which we are going. So basically generating materials accelerator platforms, which combine the autonomous robotics and computer vision and machine learning and generative AI in order to produce the data as quickly as possible, and also at the same time analyze it as quickly as possible. Yep, that's about it from me. Thank you.
Okay, thanks, Antti. Now it's time to dedicate some time to the question and answers. We are reading. It's very appreciated that there are a lot of people who raised very good questions. The first one is about the limitations on transparent wood. Actually, there are some limitations concerning the processing and some limitation concerning the applications. Concerning the processing, we have the possibility to treat hardwoods, softwoods, to delignify them, to make a sort of bleaching, removing the chromophores, but only when the size and the thickness is not too big. What do I mean? Usually, if you search on the literature, scientific literature, you see that most of the specimens of transparent wood that you are able to process are around 10-12 centimeters by 12 centimeters size. We are now, thanks to one of the partners, University of Sassari, we are now approaching to prepare transparent wood around 20 and something centimeters square. So we are increasing the size. There's another limit concerning the fact that when you infiltrate a resin, you should sell it, the resin, in the most appropriate way. That is to say, the refractive index of the resin should perfectly or really quite perfectly match that of the lignified wood, the treated modified wood. But this is possible only when you are able to measure very precisely the refractive index of the lignified wood. And this is still not very easy to perform. As you heard during the presentations, there's no exploitation of transparent wood. There's only up to now a possibility of getting a quite large size specimen of aesthetic transparent wood that is not fully transparent but keeps the texture. So if you want to produce bigger samples of transparent wood, you have to, up to now, it's possible only by using the aesthetic transparent wood. These are more or less the current limits concerning the technology behind and the chemistry behind transparent wood. Do not forget also that apart from, as you heard during the presentations, apart from some the possibility of using some biosourced infiltration resins or resins having a quite high carbon, bio-based carbon content nowadays, the best and very well optimized resin systems for transparent wood are mostly acrylates. You need to move from fossil derived acrylates to something that is more sustainable. Concerning the biodegradation, well, it's something that wood is biodegradable as because it is intrinsically biodegradable. We should have, let's say that this part has not been really fully understood so far, just because it is a very young material, and it's not possible to foresee, or up to now, nowadays, it's not possible to foresee the end of life, and in particular the biodegradation. Biodegradation does not depend only on the type of wood, but also on the resin that is infiltrated. So it's possible to use biodegradable polymers for infiltration, and it's reasonable to expect that the infiltration of bio-based polymers does not impact and does not affect the overall biodegradability of the wood, of the transparent wood. LCA analysis has already been exploited, but there are not so many scientific articles that describe very clearly the life cycle assessments of transparent wood. We could expect that there could be some progress about the end of life, as it is a very, very hot topic for all the current materials used in different sectors, and so also the end of life for transparent wood should be taken in a proper consideration. There's a comment on the flexibility of transparent wood. We can show you what happens. This is transparent wood infiltrated with an acrylic resin. The flexibility is very, very related to the type of wood that is the lignified, and the glass transition temperature of the resin you infiltrate inside, or the polymer you put inside the wood channels. So it is a combination. We could expect that, and also the flexibility depends on the thickness of the transparent wood sample. Since there are also, you can search and find in the literature, in the scientific literature, some very nice articles dealing with very thin transparent wood films. Some researchers have demonstrated the possibility to have really a very, very, very flexible material that could be exploited also for device in the flexible devices, so electronic devices. So there's enough space to also with a proper combination of the type of wood and size, thickness, and all the geometric parameters with the resin to have to tune in a wide range the flexibility of the final material. Upscaling is, what about the upscaling possibilities? Upscaling is something related to, in my opinion, mostly to the possibility of providing big size samples of transparent wood. For some windows glazing, maybe a sort of mosaic. You can combine tiles of small tiles of transparent wood, and you get something that could be also from an aesthetic point of view very, very, very nice. But it's something that has to be further investigated, I would say. I'm looking. Okay, these are more or less the questions that raised, and we thank the people who made comments on that. So there's a final pool, but we are approaching the end. We just ask you a few questions now. And also, this is the first webinar planned for our AI-TranspWood project. There will be a second webinar more dedicated to research outcomes that will appear during all this period at approaching the end of the project. It seems that anyway, 93% of the people are still interested in participating in future initiatives, so we really appreciate that. We will try to convince the other people. 7% of people who did not express, don't know exactly if they will be possibly enrolled for other initiatives. Anyway, these are our social media contacts. We need your we need followers, and you see you have also the website and the email, the general email, and if you scan the QR code, you will go directly to a website. Well, the website is continuously updating, and so you will see the advancements of the project. And then last thing, don't forget that, because it's quite important, and it will be a workshop that will be held on next June the 13th, 2025 in Turin, in Torino. The Valentino Castle is an historical royal residence and also one of the few UNESCO sites. Really nice. We will have a very, very nice room for the workshop. That will be one-day workshop. And if you wish, if you have the chance to come to Torino, it's in the city center and also near the Po River, very very green area of Torino. If you have a chance to come to Torino, please try to attend this workshop. We will put all the info on the website, and you will have the program of this workshop. So really thanks all for your participation, and let's try to stay tuned.